Hello everyone, Peter Newman with you. AHRI Insight this week is about how resistance to one herbicide can make a weed super sensitive to another herbicide. It's sometimes called negative cross resistance, has great practical applications in the field. It's the research of Huan Lu. Huan Lu is an AHRI PhD student from China, supported by the Chinese government, and he studied the atrazine resistance mechanism. What he found was the 264 mutation. Now that is the most common resistance mechanism for a weed to be resistant to atrazine. In fact, it's the same mechanism that we have in TT Canola. Back in the day in Canada, they crossed a atrazine resistant weed with canola, and the result was TT Canola. Well, that 264 mutation is also very common in wild radish, and it is a very strong mutation, as you will know from TT Canola. So the 264 mutation causes extremely high atrazine resistance in wild radish. Several litres, 8 litres per hectare won't touch it. What happens is, if we have our enzyme here, atrazine is trying to bind to the binding site in that enzyme. It's the D1 protein, it's part of the electron transport in photosystem 2. Atrazine tries to bind, but it can't form the hydrogen bonds that it needs to bind to that enzyme, and the herbicide doesn't work. On the other hand, what Huan Lu has found is that wild radish with this 264 mutation, one slight little change in the DNA code that changes one amino acid in the chain of this enzyme, makes that plant super sensitive to bromoxynil. So bromoxynil comes in to bind. It is trying to bind, and it can bind. It's binding at the same site, but a slightly different binding site. And not only can bromoxynil bind, but it makes an extra hydrogen bond and binds extra tight. So the LD50, the rate to kill 50% of the population, in a susceptible population, it's 49 grams per hectare of bromoxynil to kill 50% of a susceptible population. Of a resistant population, an atrazine resistant population, it's only 15 grams per hectare. About a third of the dose that is required to kill this atrazine resistant radish compared to a normal susceptible radish. So this has really good ramifications. If you are seeing that very high level atrazine resistance in the field, bromoxynil can be a great option. Huan Lu also talked about the 274 mutation. It's the first time this mutation had been described in wild radish. That gave low level resistance to atrazine, diuron and metribuzin, but no resistance to bromoxynil either. Now with the 264 mutation, we do get some metribuzin resistance as well, but perhaps not as high level resistance as atrazine. It's a little confusing, but the good news is, if you have that very high level atrazine resistant wild radish, if it is the 264 mutation, which is a very common mutation, that wild radish will be super sensitive to bromoxynil. More information, check out AHRI Insight.